The next sorting algorithm is called bubble sort, and it works like this. Here I have an unsorted list of elements which are not sorted according to their size. But this is exactly what I want, to transform this list into a list which is sorted according to size. And I begin with the first element, which is Peter. He is on the far left and is the first person. And I compare Peter to Tom, and we can see Tom is smaller than Peter. So Peter and Tom are going to be swapped. Now I compare Peter to Theo. Here it is clear to us that Peter is smaller than Theo, so nothing will change. Then I compare Theo to Anna. Anna is smaller than Theo, so they will be swapped. And we go on. I will compare Theo to Hans, and Hans is smaller than Theo, so they will be swapped. Next, Theo is compared to Fred. Fred is smaller than Theo, so they will be swapped. And the last element is Lisa, so I'm going to compare Theo to Lisa. Lisa is smaller than Theo, so they will be swapped. And because I always compare in two persons with each other and pull the bigger person to the right, the biggest person I could find will be on the far right. And the biggest person stays there, no matter what happens next. So I place this pencil right here, so that we know, okay, in here I don't have to search anymore. This person, called Theo, has found its final place already. Now the algorithm restarts. I compare Tom to Peter, their position is correct. I compare Peter to Anna, their position is also correct. I compare Hans to Anna, and Anna is taller than Hans. So they have to swap. Then I compare Anna to Fred, their position is correct. I compare Fred to Lisa, and Fred is taller than Lisa, so they have to swap. And again, I have pulled the biggest person, in this case Fred, up to the right. And he rises like a bubble through water. That's why the algorithm is called bubble sort. And now I know Fred stays on this position. He has to be the second tallest, so I will mark this with my pencil and restart again to compare the remaining elements. I compare Tom to Peter, their position is correct. I compare Peter to Hans, their position is also correct. I compare Hans to Anna, their position is also correct. And I compare Anna to Lisa. Their position is not correct, so they have to be swapped. And now I know I don't have to search any further, because Fred is already on his final position. And I know Anna is the third tallest person, and we restart again. Tom is compared to Peter. Peter is compared to Hans. Hans is compared to Lisa. And here we can see that Hans is taller than Lisa. And now we have returned to the pencil. So we can finish, and Hans is the fourth tallest person. And we restart again. Tom compared to Peter, Peter to Lisa. And we finish with Lisa. Lisa is the fifth tallest person. And now only Tom and Peter remain. And we have finished again. Peter is the sixth tallest. And then we have only one element remaining, which is Tom, and the list is now sorted according to size. And in the worst case, the bubble sort algorithm would have to execute n squared comparisons, because we have to compare every element to every other element, and then we have to compare the second element to every other element, and then the third. So every element has to be compared to every other element in the list. That's why I have n times n comparisons, and that's why we have a complexity class of n squared.